In this video, we are going to be focusing on problems that have to do with calorimetry. Let's assume you are given this kind of problem which says a coffee cup calorimetry is filled with 61.4 gram. So if we hear the word 64 with a gram, this simply indicates that this is our first mass. So they said a coffee cup calorimetry is filled with 61.4 gram of water at 19.3 degrees Celsius. So let's assume this is coffee cup calorimetry. So and it is filled with water. Let's just assume we have water inside. So and the mass of this water is 61.4 grams. And it has temperature. The temperature for the coffee cup calorimetry, which is T1, you can just denote it with T. This is what? 19.3 degrees Celsius. They said a 138.25 gram sample of iron. This simply means that they put iron inside. Just with the coffee cup calorimetry, it has its own mass and temperature. This iron which is currently inside also have its own mass and temperature. In this case, the mass of the metal which we put inside the coffee cup calorimetry is what? The mass is 138.25 grams. In this case, here they said sample of iron is heated to 89.98, meaning the temperature here is 89.98. If you look at this problem, we have two different masses and two different temperatures. In the case of iron, we have 138.25 gram. Temperature of iron is 89.98 degrees Celsius. In the case of coffee cup calorimetry, which I draw it in red, this is 61.4 gram and the temperature is 19.3 degrees Celsius. Notice that they have different temperature and different masses. As time goes on, if you insert the metal into the coffee cup calorimetry, there will be a moment which the temperature will be at equilibrium. In this case, we call it TF, which is final temperature. That is when the temperature becomes at equilibrium state. Here the question says, what is the final temperature of the system once it becomes at equilibrium? So before, without any waste of time, the formula we're going to use to solve this problem, we're going to say S multiplied by M multiplied by dt plus S multiplied by M multiplied by dt. So notice that dt, this simply means change in temperature, and both of them have to have the same change in temperature. Since we are asked to find the final temperature, both of them are initial temperature. We are going to be subtracting them from the final temperature, but at this point the temperature is unknown, and that is what we are asked to find. So in order to differentiate this, we can simply say S multiplied by M multiplied by delta T, and we are going to indicate it with iron, plus S multiplied by M multiplied by delta T, and in this case we are going to indicate it with what? Cup. That is the coffee cup calorimetry. So notice that the S here simply means specific heat capacity. M is the mass, dt is the change in temperature. So here, in the case of iron, specific heat capacity is constant for iron, which is what? 0.45 multiplied by mass. Mass of iron we said is in gram, which is what? 138.25. What about the delta T, which is change in temperature? We don't have the final temperature. We're going to denote it with TF minus initial temperature is 89. So, but you can choose to write your data. For it to be easier, you can say data, let's say iron, and let's say cup. Mass is what? 138.25. Temperature is what? Temperature is 89.3 98. In the case of cup, we have the mass to be 61.4 and the temperature is going to be 19.3. So all we need to do is just to insert this value. So in this case, we are dealing with what? Let's shift these things here so that we can write properly. So what is the change in temperature in iron? Iron, we have what? Final, which we are looking for the final. But in the case of iron, we have temperature of 89.98. This is simply going to be 89.98. Remaining plus specific heat capacity of water is constant, which is what? 4.18. So what is the mass of water here? In the coffee cup calorimetry, this is what? 61.4. What about the change in temperature? Change in temperature is simply going to be the same thing, which is going to be what? Let's write it at the top here, which is going to be delta T minus, what is temperature here? Minus 19.3. So if you multiply, if you come back to this side, if you multiply 0.45 multiplied by 138.25, this is simply going to be 62.2125. You are going to repeat this value, which is what? Change in final temperature minus 89.98 plus. If you multiply 4.18 multiplied by 61.4, this is simply going to be 256.65. So the thing you are going to be left with is what? Is delta T minus 19.3. In this case, if you notice here at the middle, we have positive sign. So meaning these values here are for what? Are for iron, and these values here are for the coffee cup calorimetry. So we need to bring back our final temperature. So we are going to rewrite 62.2125. Then you are going to multiply the same 62.2125 by 89.98. If you do that, this is simply going to be, here remember there is negative, is going to be negative 5597.8. The same thing with this case. Here, sorry, here is supposed to be TF. Here we will be left with TF, plus. Here is going to be TF into bracket. We are going to rewrite this exactly like that one. This is going to be 256.65. Then you multiply 256.65 by this. This is simply going to be this, yeah, something like that. So if you multiply it, is going to be, remember that is negative here. If you multiply by 19.3, this is simply going to be negative 4876.35. Next thing you need to do here is plus. You are going to plus this by this, this by this. In this case, 62.2125 plus 256.65. Here we'll be left with TF. If you plus this by this, this is going to give you 318.85. At the other hand side, we have negative is going to be positive. If you plus this by this, this is simply going to be 10,474.15. So next thing you need to do here, remember we have TF here. This is going to be equals to, next thing you need to do is to divide water by the iron. In this case, this is going to be what? 10,474.15 divided by 318.85. This is TF. If you punch on your calculator, your final answer is going to be 32 61.93, which is approximately 33 degrees Celsius, and this is our final answer. Thank you. In this video, we are going to be focusing on problems that have to do with calorimetry.